try to solve this problem from LeetCode Fibonacci number. So let's read the problem statement. So the Fibonacci numbers, commonly denoted as f of n, form a sequence called Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. That is, it means that f of 0, if we equate it, it will be, the value will be 0. If we pass function 1 to f, then we will be getting the output as 1. So similarly, as we can deduce that the value of n will be f of n minus 1 plus n minus 2 for n greater than 1. So let's try to first understand the Fibonacci series and then we will solve this problem. So first let's try to understand what Fibonacci series actually is. So a Fibonacci series is a series in which in sequence each number is the sum of the two preceding ones. So for first let's see the function for this. So if fn equal to f of n minus 1 plus f of n minus 2, where n is greater than 1, and for function of f equal to 0 and f1 it's also 1. So the sequence here actually looks like this. So first f of 0 is 0, then 1, then addition of this two preceding 1 plus 0 is 1, again these two 1 plus 1 is 2, again these two 2 plus 1 3, again 3 plus 2 5, and so on. So this is how the Fibonacci series looks like. So as we saw in the question, we have to solve it for this fn. So there are many solutions for this. So in this video, we will try to cover the recursive and iterative approach, and we will try to see what is the space time complexity for both of these approach. So first, let's start with the recursive approach. So here, as you can see, this is the code for the recursive approach for this. So let's try to understand what is this. So as we know, in the recursive function, it's the function calls itself, like as you can see, for if we pass an integer n, and if n is less than equal to 1, then it is returning the value of n, which is, if value is 0, then it will return 0. If the value is 1, it will be returning 1. Else if it is greater than 0, then we are calculating the sum of it, n minus 1 plus Fibonacci of n minus 2. So it will be calling the function itself. So for suppose say 5, so it will be calling the function itself. First it will be calling for 4, 3, and then the total value for it. So as you can see that for each function call, we are making the calls 2 times. So we can understand that it will be making a binary tree for this. For each node, we will be calling the node 2 times. So let's see that binary tree implementation for this. So so for number 5, as we can see, this will be called this will be the recursive tree. So 5 will be calling 4 and 3, 4 will be calling 3 and 2, 2 will be 3 will be calling 2 1, and subsequently means the number preceding two numbers. So it will be, the binary tree will look like this. So now let's try to solve it. So when we try to solve it, we have to look from the uh, leaf nodes. So as we can see, fib of 1. So as we can see, let's try to write it down. So f of 1 equal to 1, f of 0 equal to 0, and f of n is f of n minus 1 plus f of n minus 2. So 1, it will be equal to 1 and this will be 0. So here it will come, it will be added both. So here the value will be 1 and 0. So addition will be, here it will be 1. Similarly, here it will be 1. Here the addition will be 2. Again, here its value will be 1. Here also value will be 0. Addition here will be 1. Here now this both will be added. So 2 plus 1, 3. Again same we will be calculating here. So here it will be 1, here it will be 0, here addition will be, so here again it will be 1, again here it will be 1, again we will add both of this, again we will go up in the ladder and we will see 1 plus 1 2. So again we have solved, first we have solved all the child nodes for it. Now we will be solving the root for it. So 3 plus 2 5. So here our answer will be 5. Let's see. So now first series is 0 1, then again addition of both 1, again addition of both 2, again addition of both 3. Yeah. So as we can see that this is for the 0 index. Again 3 plus 2, here it will be 5. This is for the first index, this is for second, fourth and fifth. So as we can see the fifth value is fifth. So here at the finally we got the answer as 5 by solving it in a recursive manner. So let's see the space and time complexity for this. So the time complexity for is sorry, the time complexity for this would be, since for each n we are making it we are dividing it into two. So for fifth it will 4 3 and similarly. So the space complexity time complexity will be for this will be O of 2n, 2 to the power n, which is exponential since we are constructing a binary tree for it. And the space complexity for this will be the maximum depth of this binary tree. So in this so it will be O of n. So this will be the space and time complexity for this. So as we can see that the time complexity is a lot for this. So we will try to solve it in a better manner where the uh, space time complexity is less, also the space complexity is optimized. So let's see for that, let's see the iterative approach for this. So now let's see the iterative approach for this. So here now we have a function. The base condition here is the same. If n is less than equal to 1, then we are returning n. Now we are initializing two variables a and b, which will be having the initial value of 0 and 1, and we will be running a for loop from I equal to 2 where I is less than equal to n and I will be plus plus. First we will be storing the value b value in a temp, then b will be updated with the addition of these two as Fibonacci series is uh, made, and then a we will again store the temp value n in a, and the final answer will be in b. So let's try to dry run this for fib 5. So here our n value is 5. Let's try to debug it. So a, b and I. So starting a is 0, b is 1, I is 2. So we go into this and the temp value will become b 1. We will be becoming a plus b. So a plus b is again 1. So updated. A will be going into temp. So it will be updated. Again, I will be updated. It is less than 5. So again loop will run. Now it will go into the temp b. Its value will be 1. B value will be a plus b, which will be 2. A value will be equal to temp, which is again 1. Again we will be running this incrementing I. So I is again less than 5, so 4. Again temp value will be updated with b2, b will be updated with a plus b, which will be 3. Again temp a will be updated with temp value, which is 2. Again uh, I will be updating as 5, and b temp will be getting updated as b value, which will be 3. And now b will be updated plus 3 plus 2 is 5, so 5, and 2 a will be updated as temp value 3. Now again we will be incrementing I6. So now this condition will fail for I is not less than equal to n, and we have our b value which is 5. So the answer here it will be 5, which is the correct answer. So here now let's talk about the time and the space complexity. So time complexity here will be O of n, since we are running the loop till n, and space complexity will be O of 1, since we are using constant space. A nn. It is not dependent on n like the recursive version where it was dependent on n. So this is a better approach to solve both in the time as well as the space wise. Let's try to solve it into the lead code and see the results for both the solution. So here we have the first solution where we can see the fib, which is the recursive one. So let's try to submit it. So as you can see, this is taking a runtime of 8 milliseconds and some memory. And it beats 49%. Now let's try to solve our equation with that. So this is our recursive solution. So let's try to submit this. Yeah, so as you can see, this time is taking 0 millisecond and it beats 100% of the user. So as we discussed, the space and time complexity for the iterative approach is much better than the recursive approach. So this is all about the Fibonacci number. Let me know if you have any questions in the comments. I will try to answer those. And if you like the video, please like it and share and subscribe to my channel. Thank you.